Okay, today we are about to go over the homework. Today is Wednesday, September 28th, and what we're doing right now is we're adding and subtracting radicals. Okay, so the students have 5 homework questions, and we're about to do number 1. As you can see, whenever you have radicals, the main thing that you have to look at when you're talking about adding or subtracting them, you have to look at, is the radicand the same? Okay, as we see here, yes, it is the exact same. The radicand is everything under the radical. Here we have x, here we have x. Now, when you think of the radicand, think about it like you would if you were adding fractions, where the denominators, once they are the same, all you add are the numerators, and the denominator remains the same. The same principle applies here. So we have 5 minus 2 equals 3. And again, we keep our radicand the same. So our answer is simply 3 radical x. Now let's move to number 2. And again, the student should already have these problems written down. It's also important that you only look at this video after you've attempted the problems yourself. Okay. Again, what do we look at first? We look at the radicands. Are they the same? No, they aren't. First, you have to simplify. Whenever you simplify the radicals and it has a coefficient or a number on the outside, first you start by what you have under the radicand, which is 20. Factors of 20. 5 times 4. We can stop with the 5 because it is a prime number. We look at the 4. It's not a prime number. What are 2 more factors of 4? 2 and 2. The students are taught to write out all the prime numbers. 2, another 2, and a 5. At this point, you circle your pairs. Well, what do we have a pair of? We have a pair of 2's. Circle the 2. The students know that the 2 goes on the outside of the radical, but there's already a number on the outside. When that occurs, you simply multiply 2 times 3. That gives you 6. What's left on the inside is the only number remaining, 5. So 3 root 20 simplifies to 6 root 5. Plus, now we have to break this down. Again, we start with the radicand. We have 4 times 2. 2 is a prime number, so we stop there. This 4, we keep going because it's not a prime number. And we have 2 times 2. So what do we have? We have 1, 2, 3. 3 2's. What do we do first? Correct. You circle the pair. The pair goes on the outside. Well, there's already a 2 here. So you have 2 times 2 is 4. All that's left is this 2. 4 root 2. Now, if you're watching this and you're a parent or a student that has forgotten, or maybe this is the first time you've seen this, you may wonder, why is this not 2 times 2? Well, I tell the students to think about it like shoes. If you buy a pair of shoes, it comes in one box. So this pair of 2's only counts as 1, 2. So we have a 2 times 2, and that gave us the 4. Now we look at this. 6 radical 5 plus 4 radical 2. Are the radicands alike? No, they aren't. So we can't add these. This is our answer. Moving on to number 3. Now, number 3 presents a slightly different set of challenges because it has a variable with exponents. But as you're going to see in a minute, that doesn't change much. Okay, whenever you see this, first we're still going to deal with what's under the radicand, 20x cubed. But first we're just going to deal with the 20. I'll show you what we're going to do with the variables in a second. The 5 is prime, so we stop there. The 4 is not prime, so we have 2 times 2. Okay, all prime numbers. So we write them out: 2, another 2, a 5. Now the only difference is you also add the 3 x's. 1, 2, 3. So now we still circle our pairs. We got a 2 that goes on the outside of the radical, and we also have a pair of x. 2 times x is 2x. And all that's left is a 5 and an x. You also multiply. Whenever you have more than one thing left in the inside, you multiply it. 5 times x is 5x. So now let's do the same thing to 12x cubed. Prime number, so we stop there. Look at what we have here. We have a 2, another 2, a 3, and 3 x's. 1, 2, 3. What did we do? Correct. We circle our pairs. We have a pair of 2 and a pair of x's. So that's going to be 2x. Radical, what's left? The 3 and the x. Now, you may be looking at this and saying, well, they both have 3x. Can't we combine them? No, we cannot. The exact same thing must appear in the radicands. This is a 5x, this is a 3x. Since they aren't alike, this is our answer. Let's go on to number 4. Root 9 minus root 16. Now, for those of you that are good with perfect squares, you could immediately see the square root of 9 is 3 and the square root of 16 is 4. But let's just say you didn't know that. Well, we have 3 times 3. There's a pair. That goes on the outside. When there's nothing left to go on the inside, you don't write the radical symbol. So we have 3 minus we have one pair and we have another pair. So that would be 2 times 2, which is correct, 4. There's nothing that could go under the radical, so we don't make a radical sign. 3 minus 4 is -1. This is where the students have to brush up on their integer rules. It's extremely important in the 8th grade. The last homework problem is number 5. We have 2 radical 9 minus radical 16. First things first, we look under the radicand. We already established up here that the square root of 9 is 3. So we have a 3 that goes on the outside, but we already have something on the inside. What do? Correct. Multiply. That equals 6. Now, is it radical 6? No, it is not, because there's nothing that can go under the radical. So it's simply 6. Minus We already said what the square root of 4 was. The square root of 16 equals 4 because there's 1 pair, 2 pair. 2 times 2 is 4. So our answer is 2. Now, I have completely went over the homework on adding and subtracting radicals. The students need to expect a quiz over this very material tomorrow. If you have any questions, comments, or concerns, please leave them on the blog under View Comment.